Okay, so let me continue because we already over the time. So we said 2 to the power of x multiplied by 2 to the power of 1. I could rewrite that as this. It means the same thing, right? Because 2 to the power of 1 is the same as 2, right? Looking at this second term now. 2 squared to the power of x. I know this rule right here. A to the power of n, this whole thing raised to the power of m. What I was showing you at the beginning of the class, I told you that these numbers, if I switch them, it wouldn't affect anything, right? So if I had 2 cubed and this whole thing squared, if I decided to switch the numbers, so I say 2 squared, and the answer I get, I cube it. You see this and this, they're going to give me the same answer. So if I switch these numbers, my answer is going to be the same. So what could I say then? A to the power of n, and then this whole thing raised to the power of m would be the same as a to the power of m, and this whole thing raised to the power of n. If I switch the numbers, so instead of n, m, I have m, n, it wouldn't make a difference, right? So that's what I'm going to do here now. Let me just erase this yellow part. This is what we're looking at. 2 squared raised to the power of x. I would treat the 2 right here as my n, and then the x would be my m. But looking at this, it says that if I switch these numbers, it wouldn't affect anything, right? But why would I switch the numbers? Because my aim is to get 2 to the power of x. That is what I want. That's my aim. My aim is to get 2 to the power of x. So I can say 2 squared raised to the power of x is the same as 2x squared. All I did just now, I switched these. So 2 and x, I just switched them to get x and 2. You good with that? Yes, no?
Yes, miss.
Okay. So this is a rule that I showed you, and this is the rule that we would apply for this last one here. So the same a and to the m. We said that this would give me a and m. So what I'm doing, I'm multiplying the 2 powers. And that's what I would do here. I see 2 to the power of 4, and then outside I have a power of x minus 1. So all I'm going to do, follow this rule, and I would multiply my powers to get 2 to the power of, if I multiply 4 by x minus 1, I'm going to get 4x minus 4. Next line. So I know this good. How do I know that this is okay? Because remember, my aim, my whole aim of simplifying was to get this. The aim is to get this, the 2 to the power of x. So now that I have 2 to the power of x here, I know I'm good with that. So okay, I could just write that again. I have 2 to the power of x squared. I already have my 2 to the power of x, so I know that's okay. I could just write this now. However, for this one, we don't have 2 to the power of x. And our aim is to write it like this. So how exactly do we do that now? So what could I say? 2 should be minus. If I said, I know that there's a rule that says, actually, should I? Yes. Let me do that rule. So it has a rule that says a to the n divided by a to the m is going to give me a to the n minus m. So I see 4x minus 4. So what can I say here? Okay, according to my rule, this is the same as 2 to the power of 4x divided by 2 to the power of 4. Looking at this ruler, a to the n divided by a to the m. If I said 2 to the power of 4x divided by 2 to the power of 4, that's the same as saying 2 to the power of 4x minus 4, according to this rule. You good with that? Yes, no?
Yes, miss.
Yes, miss.
But we could, remember the aim is to write it like this, 2 to the power of x. And we didn't reach there yet. 2 2x plus 2x squared. Our aim is to write this like this. We need the 2 to the power of x, right? So what can I say now? Anybody has any idea of what you would say now? Anybody? Oh gosh, I need space to. Hold on. Can I erase? Okay, like the things up there. Can I erase it?
Yes, miss. Okay, so my bad there. I cleared it in by mistake. Oh my gosh, I cleared it in by mistake. Okay. So this is what we had, right? So x, it was 2x squared. And then we had this 2, 4x, and then this whole thing divided by 2 to the power of 4. But I told you that we need to simplify this even further because our aim is to get the 2 to the power of x, right? 2, x. So I could write this. I could rewrite this again. So this is what I have plus 2 of x squared minus. So remember this last root, this last root here, a to the power of n. Wait, what root is this then? This is the same as a to the n times 10.
So what can I say here? 2 to the power of 4x is the same as, right? I could say that 2 to the power of 4x is the same as 2 to the power of x, and this whole thing to the power of 4, according to this rule. 2 to the power of 4, that's 16. So instead of writing 2 to the power of 4 here, I could just write my 16. What was the whole aim of this question? They told us that y is equal to 2 to the power of x, and they wanted us to write the expression in terms of y. Now I could do that. So 2, hold on, it's not 2x, it's 2 to the power of x. Since I know that y is 2 to the power of x, I could rewrite this as 2y, because y is 2 to the power of x, so I can rewrite this as 2y plus y squared minus 2x to the power of 4. We know that 2x is y, so I could write this as y to the power of 4 divided by 16. So how was that? This would be an answer because they wanted the expression in terms of y, and you did that. 2y plus y squared minus y to the power of 4 divided by 60. How was that? You understand what I was saying?
Yes,
I
ma'am.
think I'm following this.
You think you're following, and you need to know that you're following. Anything that's confusing to you on the board, like on my screen right now? Anything you don't understand at all? Or even if you think you understand, but you're not sure if you understand, let me know so I can clear up any doubt.
Yes, miss, I understand.
Okay. Well, hold on.